Hello, hello. Ooh, whoa, okay, cool. Hi, everyone. Thanks for sticking around until late today. Um, so I'm a bit tired because I did not have a lunch nap as I usually have because I had to fix the slides and stuff. So I don't know, maybe this projector is haunted or something because every time I come to Belarus to speak, I have to use an Apple laptop to present it. It's like a slap in my face. Okay, so before you all fall asleep, I need you to stand up for about 5 seconds. We have to do a little exercise so we all wake up. So please stand up for 5 seconds. I'm going to yell questions at you. No physical exercise. It's way too early. I'm going to yell questions at you, and you yell, yeah. Okay, so are you all ready? Are we all going to the after party tonight? Yes. Are you all going to buy me a drink? Can you all put your iPhones away in my last talk? No. Oh, weak. Okay, thank you. You're great. So who's actually not coming to the after party? I want to... Oh, only one person. That's sad. Like, we can be friends anyway. Okay, so there has been some confusion around the topic of my talk. I think the topic got changed 5 times. So the original title was from OOP to FP and beyond, and now it's called something like How My Programming Life Changed. So what I got confused myself. So what I did is I replaced all the coding slides with mathematical slides, and we're going to talk about simplifying bijective transformations through generic monad-based functors in Haskell, because we can. Okay, now so actually, I think by my talk, since I'm giving a keynote, I actually threw out a lot of code, and I want to talk about simplicity. Yeah? Running kids on a field, and like. So this is me 2 years ago, hanging out with my friends. Can you spot me, because I can't? And also, this projector is such a great projector. The image quality is great. So this is my friends and myself on the couch where I grew up. I mean, I didn't grow up on a couch, but you get the idea. This is when I was like, I don't know, 8 or something. And I think I started programming around that age. I mean, programming, not like, I wasn't like writing formulas on the wall like Albert Einstein or something. I was like trying to learn how to program, and it was like really, really, really hard. And I wanted to learn programming because I had a Mac before it was cool. Like back then, they were called like Classic 2 and Macintosh Quadra and all this kind of stuff. So that was actually the real shit. And I wanted to program my own game. That's why I started programming. I'm not kidding. And I remember exactly that I was learning C++ with an English book, not speaking English at all, or like basic English, like hello, how are you? And I remember exactly that I was struggling to learn the concept of a function. So I realized, I understood a function is basically a component where you can have reusable code. But what I didn't understand was that the incoming arguments, like the name of the incoming arguments can be arbitrary. Like in the function, you can call it A and B, and when you call that function, those variables don't have to be called A and B. So I didn't get that idea, and I remember exactly, like I was chatting to my dad about this and felt really stupid. And at one point, so he told me, like, man, it's like a component. You just throw something in, and then on the inside, you can do what you want with what you pass in. And that's exactly the same with the name. Like you can name any way you want. And that's when I kind of realized, awesome, this is a really, really, really simple concept to make reusable code. It doesn't even have to be for reusable code. It can just be something to simplify your code, because a function, and that was the intriguing part, doesn't know anything about the outer world, and the outer world doesn't know anything about the function. So I was really intrigued by that concept, and I, of course, didn't program C++ anymore because I wanted to stay sane, so I got into PHP, all the good stuff, and Perl. And even in Perl, I managed to use functions and write nicely encapsulated code. By the way, I'm going to say the word encapsulated 100 times in this talk, but it's okay. So I got into Perl, and I learned a little bit about object orientation, because I know you have no idea, but you can use Perl in an object-oriented way. And so that was the first encounter with like having functions and using objects, and both concepts were really like helping me to struggle with the complexity of my amazing game that I was programming. Actually, I didn't manage to write anything usable. And so that was beautiful. And then I got into Ruby on Rails. So I switched from my imaginary game to actually writing software for the money and the fame. And I got into Ruby on Rails programming. And the same concept again, you had objects, you had functions, you could use encapsulation if you want, you could not use it and write really messy code. What really bothered me, and everyone who has seen me already knows that I'm going to rant about Rails a lot, and yeah, so here's supposed to be a big code slide showing a model in Rails, which usually contains like lots of validations and callbacks, the way Benjamin was talking about, and you know, you have like SQL code and decoration code and domain code, business code, and then more callbacks that get triggered. So it's really, I don't know, I found it not very intuitive, and it's the same with the controller in Rails. Like you just throw in any kind of code for authorization and callbacks again, and you know, if current user does this and else do that, and it didn't feel, even though I had methods, even though I had functions and objects, it didn't feel simple. Yeah, it was not. I don't know. It felt simple in the first 2 hours, and then I was struggling how to structure that code. And so what I did was I started to play with Rails and with actually not new ideas. I started to play with the ideas of having components in Rails in an environment that does not want to have components. So the first gem I came up with was cells. Oh God, this is so bright. So lucky I have so many dark slides. And then, so the first thing I did was I invented Amazon and got really rich, as you can tell. I got told I look like a homeless today. So what cells did was helping to write widgets, literally like fragments, to encapsulate fragments of your UI into a smaller component. So I did not write Amazon, that's not me. And the concepts I used was nothing special. It's just, instead of having like this partial thing that is floating around as a template, you have a class, and that class has only one responsibility, which is rendering a partial, but in an encapsulated way. Yes, I had like this class and the show method, and you had this render cell call, and then you could render that fragment in a nicely scoped way anywhere in your application. And the great thing was, you could also test that component, and it would do the exact same thing in a test than it does in production. And you know, we added caching and all this kind of stuff, but the idea was still, you call something and it does exactly the same, because it doesn't know what's on the outside, and the outside doesn't know what's happening on the inside. Cool thing was DHH liked it. Here's an email from 2008 where he kind of told us that he really appreciates the project and he wants to merge it into Rails core. Luckily, this never happened. By the way, DHH is the guy who also finds it really cool to use concerns and 35 different modules. I'm going to show that slide in a second, a little bit bigger. So yeah, I don't know, the opinions have changed. The next thing, or another example of this mindset was that we started to work on reform. Reform is exactly the same concept. You have a form in your website, and you want to write the associated code for that form. And you don't want to use accepts nested attributes and model and controller. You want to have, again, a class. So you have a very simple form class, and all the form class does is it represents all the fields and the validations for that form we just saw. Yeah? So it doesn't matter, the code is not really relevant, but you define the fields and the validations in a class. So again, in a nicely scoped way. And the same phenomenon, again, you can test that form and those validations for that context in a test. And it will do the exact same thing in production. So it's really, I like the idea of having small scoped objects that do one thing, and you use that object in different contexts, and you can always rely on the outcome because you tested it. Something that is not really a normal thing to do in some Ruby on Rails applications. So we introduced a bunch of those kind of gems that help you. It looks like fun, right? So that helps you to deal with complexity by introducing small components. And at the same time, I mean, this tweet is 2 weeks old or something. DHH is still promoting the idea of, hey, let's have, let's include 55 new modules or concerns into one model and add 5,000 new methods to one model, and you have a model already has 578 methods, and you add a ton of more code and behavior, and this is not simple. It looks really cool in the beginning. You're like, hey, cool, I add this concern and that concern and encrypted password, and oh, it's cool, like my app is so cool. And you have no idea what it does, and it adds callbacks, and it adds, I don't know, like scopes and all this kind of stuff, and you add this behavior in a very magical way, and it seems magical in the beginning, and then at some point you realize, oh man, I have no idea what is going on with my, like when I save attributes or something, I don't know what's happening. So it is not simple. I love those beautiful inspirational things when people have those slides and you look into the horizon and the setting sun or something, and you have this like inspirational quote saying, I don't know, like, change your thinking and you will change the way you think, or something like that. Okay, so I wasn't happy with, I mean, I am happy with the Ruby community, with the Rails community. I like there's lots of people really critical, because, I mean, if you want to work with the Rails way, it's fine, but if you think you need more encapsulation, it's also fine, so no one is going to kill you. And so what I did was I had this form object and cells and a few other gems, and I decided that I am still missing some element because my code in the controllers and in models is still a bit messy. So the next thing, that's actually we, as in several persons, because that's when we started to work on the framework called Trailblazer, and everyone here is now, oh no, he's going to talk about Trailblazer again. It's like, weird, you invite someone from an open source project and he talks about that project. So what Trailblazer did is, it only focuses on business logic, yeah? So the idea was you introduce classes, again, same concept. For example, comment create, and you just call that class, and that class will handle all the code that is needed to create a comment. So the controller delegates to that service object, and then handles the result with if and else or whatever. So that resulted in really nice controllers and really slim models. So the models would only do active record specific things like SQL abstractions, because that is what active record is supposed to do. So that was actually a really beautiful thing. So instead of having all this logic, oh God, I need my sunglasses. Instead of having the model like full of code for different contexts, what we did is we had all those different contexts in different classes nicely arranged. So you had a create, you had an update operation and all this kind of stuff. So you could, anytime you would be running an operation, you would know it only deletes something and all the associated code, or it archives a comment or something like that. So the key was, again, simplifying by introducing boundaries, yeah? And so the key element, as I already noted, was the so-called operation, which is a class that delegates to different objects, like form objects for validations, or to the active record model for persistence. So all the operation does is delegating to different stakeholders to accomplish a task, for example, creating a comment or something like that. So it's a very simple thing. And again, the idea of encapsulation and orchestration. And here's an example of one of the operations in Trailblazer 1. So actually, it doesn't really matter. Again, the idea was have a class to do one specific thing, creating a comment, and do not have that code flying over across the framework in 50 different places. So if you look at an operation, you know, okay, this is what's going to happen when I create a comment. And this is only like 2 technical slides now. So the idea was you call an operation, and that will invoke the necessary code, and you pass in the parameters that, or whatever you need in that process to build a comment in this example. And it would return a result object. I'm going to speak about that a little bit later. So you could ask, hey, was it successful? And you could ask the operation instance for arbitrary data you wanted to have exposed. But this was a very bad decision. But I'm not going to talk about it today because everyone is tired. And yeah. So again, the cool thing was you could test an operation exactly like you test a cell in a form object and whatever by having the exact same API in a unit test, and you could test the outcome and whatever, the behavior, the side effects. Really cool and super simple. And another big thing was that you could also use your operations as factories. So you finally have an actual factory code that corresponds to production effects. Yeah? So create a comment with all the associated code, and that will create a comment object with all the data and attributes set the way it will be in production, instead of using factory girl that kind of creates a leaky test abstraction state. And that time I started to work on some LeanPub ebook. It's a lot of fun to write a book about a framework you're also writing at the same time, and then you change something in the framework, and then you have to come back to the book and rewrite the book chapter-wise, and then you have to rewrite the framework because you figured out that what you actually were writing about sucks. And that was a big problem for me, and I will never do that again, to write something about something that is changing. So maybe I should be a history author or something like that. The other problem was that, so the book was called A New Architecture for Rails, yeah? And it's called A New Architecture for Rails. It's not called a new architecture that is going to solve all your problems and write the code automatically and has all the features you ever wanted. Like, people were literally thinking, they were using Trailblazer for like 5 minutes, and they said, oh, that sucks because you don't have, I don't know, Finder objects, and oh, that sucks because your policy code doesn't support, I don't know, Guardian or something, like some weird gem. Or, you know, they were like instantly ranting about it because we didn't solve all the problems they had. Oh, we still have to write code. It sucks. You can laugh, you can laugh. So every time someone came up with you know, an issue, it reminded me of this, no, I will not fix your computer, you know, because when you help someone getting Microsoft Word running and suddenly their email account doesn't work, it's like, hey, can you come and fix my computer because since you touched it, my internet is broken. And that's the same with Trailblazer. Like, people started using Trailblazer and suddenly they were like, oh, by the way, I mean, they didn't call me, they didn't have my number. But like, since we use Trailblazer, I don't know, our loading is broken, or, you know, we have a foreign key reference error or something like that. And it's like, man, it has nothing to do with Trailblazer. Like, stop blaming us. So I recommend you never invent something new and write a book about it, because book automatically means everything is perfect and everything's working great. Okay, whew. I'm getting started. Okay, so just a little detail about a very, very bad decision I've made in Trailblazer 1 was, so we had this idea, let's have a comment create class that creates a comment and all the associated stuff you need and want. And so the only way you could inject or implement your own behavior was by creating a process method, and then in that process method you would have like, sometimes you had like 200 lines of code to create a comment because you needed a lot of things. Like, you know, you didn't have callbacks anymore, so every callback, in quotes, would be handled from the process method. So sometimes the process method was actually more code than it was before. Yeah, so because I came from the idea of like object-oriented programming. You have an object, and that has a method, and that method calls other code, and that code calls other code. So that's kind of the idea in Ruby. That's how we think. We think in nested triggering of code. Yeah, and the problem here was that Trailblazer predefined behavior. So yeah, so here's an example of the call stack. Don't try to understand it. What I'm trying to show is that, for example, to run something like a policy, that was hard-coded in the operation. So you run the operation, you call the operation, and it would do a lot of stuff, and then at some point it would run the policy, like to check if the current user is allowed to do that or whatever, and then it would do a lot of other stuff, and then finally run your code, and it was really messy, and it was really hard to see through when is what happening. And then people started to say, oh, by the way, I want to run the policy after I run the validation or something like that. And it was really messy. But this was the only thing. I mean, I didn't know about like functional concepts yet. So I thought, this is idiomatic Ruby. This must be right, yeah. So like, but the effect was that if you, for example, wanted to override how the policy worked, don't worry about the details. You had to include a module, and then sometimes you would include another module to override the original policy behavior, just as an example, and then someone else would include another module too, and you see that everywhere in Ruby, you know. And then sometimes people want to override the method that was included before, and it's like, you know, this whole concept of including modules into objects and then using super to call the original behavior, but then you add some other stuff. It is super messy, and it's like a core principle of Ruby. And I thought that was amazing. Yeah? In the beginning, I thought super and overriding with modules, and it's so complicated. I still don't get how it works, you know, because you have to write modules if it's whatever. And so I kind of started to realize maybe the great plan in Ruby to have everything overwritten with modules and super and maybe it's wrong. You know, maybe this is the wrong abstraction. And at the same time, I was reading a book, really interesting, about how this guy, Jeff Hawkins, he invented the Palm Pilot. And this is kind of his take on how the brain works. And so he basically concludes that the brain is working in abstraction. So to solve a problem, it cuts the problem into smaller pieces. And in the end, you would only remember something really simple. And that's kind of, I was reading that while I was like fighting with super and include. And it's like, this is not how the brain works. Like, why is it so complicated in Ruby if the brain wants to do the opposite? So it was really clear to me that we have to like find something new. So we had all those beautiful objects. We had this operation with the process method and this problems with stack trace and all this. So it was pretty clear to me, maybe I should leave the Ruby way and find out how other languages do handle with, deal with those kind of problems. Yeah? To remind you again, we had a sequence of actions to perform, and sometimes you want to change the sequence of actions, and with like super and include, it's super messy. So let's look at functional programming. And I always think of functional programming like mathematics, and you have to like call functions, and they are like bijective transformations, and it's like, what the fuck? Like, it's just it's a function. You pass something in, and you get something out. That's functional programming in a nutshell. And you don't have state in ideally, yeah. And when you look at the operation, the way an operation works, you see a function call. You see input that we pass into that function call. And there will be some result that is returned from that function call. And don't worry about the details. So that is kind of the idea of functional programming in Ruby. Okay, you call something, you pass something in, you get a result. And what happens in that function is completely irrelevant to the outer world. Ideally, in Ruby it's really hard because we have mutable state. And I could talk about mutable state for 15 hours now, but I want to get to the pub. So I wanted to get away from this include and super nightmare and undef method, and oh my god, it was so terrible. So I wanted to get away from this idea of having to know about call stacks. And so what we did instead was we came up with this really simple DSL that lets you define the sequence of actions to be performed with this step API. Yeah? So basically what you just saw visualized would look like this kind of activity or this kind of diagram. Yeah, you have a chain of events, and sometimes you can branch off and handle some error, blah, blah, blah. So this idea, Benjamin was mentioning it, is nothing new in the programming world. It's called railway-oriented programming. There's actually beautiful websites about it, and they are not about Ruby. They are about stuff like F#, for example. So the railway thing has found its way into Ruby maybe 1.5, 2 years ago, and it's actually becoming really popular. So here's how it works. Like, you run this sequence, and if something bad happens, it will jump to the error track, that's the lower track, and if everything is okay, it will stay on the upper track, which is the, I don't know, success track or happy path. This took me about 25 minutes to draw with LibreOffice and GIMP and different layers and transparency levels, and it was a nightmare. But so yeah, if you need help with animations, I'm your man. You can give me an endorsement of LinkedIn saying GIMP and okay. So the whole idea was make it simple to define a chain of actions and make it simple to have built-in error handling, which I'm not going to talk about too much today. And that was this DSL, and it was really simple. And just because, I mean, showing this DSL is beautiful, and you have this visual model, but just to understand, so every step or every entry with this DSL is basically just a callable Ruby object. In this case, it's just a method, and that method gets a context object and some keyword arguments, blah, blah, blah. And then you can write to that context object and implement whatever you need to do in that step. Yeah, okay, so every box in the diagram is a method, basically. Yeah, details don't matter. And what also was really important is that we added the ability to nest those operations. Yeah, so you could compose more complex graphs by using our nested function, basically. Yeah, so visually this would look like this. So it's very overwhelming. So here's the thing you want to nest, and then you would call that nested thing, and then you could wire the outputs of the nested, the outcome of the nested component to like other stuff, so blah, blah, blah. It's really not irrelevant. But if you look at it in a visual way, you kind of understand it without having to understand what are outputs and what is a signal and all this kind of stuff. And that is what I loved about this new approach, that you could visualize that, yeah? And I mean, this is about simplicity, and our brain loves visual information. We don't like if, else, blah, blah, call this, call that, undefined method here, and extend. We like graphs and arrows and this kind of stuff. So I thought this was a good idea to go into that direction, to more visual stuff, yeah? And we still have the same concepts. An operation is something you call a function, a step is something you call a function, and you pass in this context object and write to that context object, and that's basically all the mechanics we wanted and needed. So never again would you have to look into the actual implementation of the library and check out where does he call what method or where does she call that method, because you had this graph thinking, the visual model of a graph. So we pushed that into the community and it was received really, really well. But people started to rant, of course, instantly. This is really cool, but how do I find out what actually happened in my code? Because I don't, like, there's an error and I don't know where it's coming from. So what they wanted was like tracing. They wanted to know, did we go that path, or that path, or that path, or that path? So they wanted to have tracing. And tracing, it sounds really simple, but I actually had to rewrite the entire mechanics for over 1 year to get this tracing going. And of course, lots of other features associated to that. But the tracing feature was the kind of beginning of another rewrite of what was already rewritten 5 times. And also, since we changed the API to that step stuff from the old style, people were ranting. This is me fighting with a guy. This is me, by the way, fighting with a guy. So he just asked, "Why did you change the API in Trailblazer 2? I have to rewrite all my code now. It sucks, man. Can you just keep going with the same API the way Rails does it for the last 15 years?" And you're like, "Man, I'm trying to simplify your life. I'm not writing new APIs and break everything to make you feel like, oh shit, I have to touch every piece of code again." So this is another thing I still don't understand. Like when open source authors write or change APIs, they don't do that to to fuck you up. They do that to make your life easier eventually. And yeah, so and the other thing was that lots of people said, this is actually kind of cool with the visual idea of like this sequence of steps, and you can use the DSL, but we don't need it. It's not Ruby. It's not like idiomatic Ruby. We don't want that. Like let's do like I want to be in control of my code. And you look at the code, it's like, and like okay, well then keep going with idiomatic Ruby if you want that. I read this at that time. I was reading a really cool book about intuition. It's called Gut Feelings. You should all read it. This book is actually amazing. So it explains how the brain does, or how people do decisions. There's usually a decision is very simple. The simpler the outcome is, the more you tend to choose that way. So the book helped me to realize this might not be good for everyone, but I like the idea of having something real simple in my code. And that book is basically saying, pick what you intuitively think is good. And that was, I found the idea of a sequential step model way better than having to nest 500,000 levels of Ruby code into in one method or class or whatever. Dolphins. A species that is about to extinct in our oceans due to too much plastic trash, which is terrible. You should all stop using straws, because that's the main reason for animals to die in the ocean. Hey, I'm not associated with Greenpeace. Okay, so we had we changed from Trailblazer with the process method and nesting to this visual graph thinking, and of course we wanted to keep pushing new things. So what we gave those people out there was tracing, so they could actually see what happened in my deeply nested graph thing and in my operations. So they could follow the execution. They could see what variables were at which step. So that was actually really cool. And we also allowed them to have more complex graphs. I'm not showing the code right now because no one is interested, not even myself. Like you could build more complex operations. You could go back. People wanted that kind of shit. Like something. If you have an error, like you want to try it again or something, they wanted that. So we gave them the ability to write crazy stuff in a beautiful way, and that's what Ruby is about. At the same time, I started to work in a consulting project for a band from the United Kingdom called The Police. They needed a new bassist because Sting wasn't performing anymore. No, I'm kidding. I actually started working for The Police, like the actual police that shoots people. Don't judge me. I work on a software written in Trailblazer that makes sure that when someone applies for a weapon, they actually get a background check on criminal convictions and this kind of stuff. Something that particular countries should probably copy. So I'm open sourcing that as soon as no one is looking at me. So the thing at the police it's actually a really cool job. So they had thousands of documents with diagrams and descriptions. This is what happens when blah, and if the guy has more than 3 criminal convictions, do this and that, and call someone, and if that guy doesn't answer the phone, escalate to the managing supervisor, and like millions of those diagrams, 100,000 of lines of existing code, and they did not match at all. So the problem was, how do we get diagrams that show us code, and how do we combine that with code that is supposed to work as the diagram shows? And that is when I discovered the beautiful concept of BPMN. That's a Java thing. It's business process modeling notation. I should be wearing a suit right now to be more serious. And so BPMN is literally about drawing the flow of your application and in any kind of level of zooming you want. That's beautiful. And so business people love BPMN because it describes their processes, so even idiots understand it. Chuck Norris likes BPMN. Donald Trump, who is a businessman, also supports BPMN. And of course, DHH loves BPMN. Not! Okay, so BPMN is literally only about, you have boxes, circles, arrows, squares, and vomiting unicorns. I mean, just kidding, there are no squares in BPMN. And so you model very complex business processes using a visual language, that's all. And you don't have to read 500 books about it. It's really not that hard. And they have this concept of pools, so you can, you can arrange collaborations, as they call it, and you have this this concept of sub-processes where you can nest activities, so exactly the same we do in operations when we nest, and then you have events and this kind of stuff, and you have throwing events that can notify about something, really interesting for you because it's touching the exact same thing, and you have catching events, which is a listener who is listening for a specific event and then starts a series of actions. So it's a really simple and understandable language that comes in pictures, and we all like pictures, right? And so I realized, hey, hang on. So we actually have something like that in Trailblazer already, which is this ability to describe what we call operations. And in BPMN, an operation is called an activity. An activity is an arbitrary graph of do this, then do that, then throw an event, then if that is the answer, do here, if that is the answer, go there. It's very, very simple. And while I was working for the police, we came up with this new, I would say, layer of Trailblazer that is called workflow. And the workflow gem helps you to define global application-wide workflows, not only creating a comment or archiving a memo. It's more about the entire workflow from the beginning, from the sign-in to 5 months later, deleting a user, what can happen in between, in a graphical way, and also, of course, in code. And it's like, I don't want to show more code and stuff because we actually want to go to the pub, but what we did was we spent a lot of money on a graphical editor so you can draw, this is a really stupid example, so you can draw those workflows visually, and we can present them to the police, and they look at it and say, oh, this is exactly what we want, and then that code can be translated to processing code in Ruby, or you can write it yourself. And what's absolutely amazing about BPMN, and I just learned about that a few weeks ago, is that by using events, you can write library activities. So here, for example, you see a one-time password login, like the workflow, and that workflow comes from a gem, the gem we call Tyrant. So we program and implement that workflow, the state machine, in a gem. And then you can use that workflow in your application code. So here's the application code for the police in this example. It's super confidential, and you shouldn't be looking at this, but yeah, whatever. And then you use what they call in BPMN collaborations. So you send events back and forth between the 2 or 5 or 17 activities, and the workflow engine in Trailblazer will make sure that, for example, you can only enter a new password after you entered the one-time password and this kind of stuff. So you don't have to worry about the control flow anymore. You worry only about the implementation of those actual boxes. Yeah? So coming back to the idea of simplicity. And so there's lots of gems that try to achieve that, you know, like active state machine and all this. I'm not really happy with them because they only focus on states, but BPMN focuses on transitions. Yeah? What am I doing to reach a certain state? And the second thing is that those state machines are supposed to work over weeks and months, and you don't need a process engine or something running in the background. So it's really cool to model really, really complex, long-running processes. And just giving a really simple example, here's one of those activities I was showing in code, and here's the collaboration, you know, the arrows between the things. This is basically how you code that in Ruby. So we provide very simple DSL, and it's nothing crazy. So you can actually tackle complexity by using existing languages like BPMN without having to wear a business suit and going to like Java conferences where you need 15 certificates to be like accepted as a speaker and this kind of stuff. So I was really impressed by, I mean, BPMN has been around for 25 years and lots of people thought about it for many months and years, and I really love the simplicity it brings to like super complex workflows, for example, and we achieved the goal of having code and diagrams match, and they will not desynchronize at any point. Yeah, and the last code slide, to show you this, it's not like a magical thing that is happening in the background. So you actually, this is a controller action, for example, and what you do is you let Trailblazer create a specific event, and then you throw that event into the process engine, and it will make sure that it runs the code and the associated activity wherever you were before. So it's not like super crazy stuff. You just call a process engine instead of arbitrary code in controller actions. And the feature I love the absolutely most is that you have, I mean, this doesn't look really appealing, but you can use tracing, again, because we use the same mechanics for everything. You can trace those long-running processes, and you can see 5 weeks ago what happened to my inquiry about Benjamin Roth. Is he a criminal? Why was he assigned a criminal equals true? What happened? And you can see all the flow, and you can log that. It's really simple to debug. And again, if you use Ruby, idiomatic Ruby with like super and overriding methods, and you have this call stack, you can't do that kind of stuff. So I don't know, the more I use functional concept and chaining functions, the more I wonder, why have I ever been using super and extend and include in Ruby? Yeah, so the future, ladies and gentlemen, are BPMN diagrams and .NET certificates on your wall in beautiful frames. To wrap this up, I was talking about simplicity. You saw a little bit of complexity, because what Trailblazer or other frameworks do is of course, they introduce new complexity. You suddenly have to know what is an operation, what is an activity, what is an event, why do I have to use a collaboration diagram? So you have to learn that, but in my ideal future, things like activities or collaborations could be part of the language itself, exactly the way we talk about strings and arrays and I don't know, what else do we have in Ruby? Hashes. The way we talk about those primitive data types, there could be advanced types in a new language or maybe in Ruby, like activities. So if you think about it in that way, it's not that crazy anymore to have this DSL that defines the sequence of events. It's kind of like it becomes a natural thing. And this is because we introduced abstractions that help you to chain. Is she ticklish? Nothing. So we introduced abstractions to help you think in higher levels. You don't think in, where did I include that module in the 25th indent of my call stack? You think in like, okay, this happens, then this happens, then this or this happens. And this is because abstractions is exactly how the brain works. We don't operate like running some code and jumping. We want to see the big picture ideally in a visual way, and that's exactly what we try to achieve, well, we're trying to achieve with Trailblazer. So I recommend you that you embrace the new upcoming stuff in the Ruby community. There's lots of other gems there, like the Waterfall is called, by Benjamin, and there's a lot of stuff happening in the Dry community and in Hanami. So they all try to make life easier by introducing more complexity. Embrace that, because it makes it will make your life better, and you will start to think in those abstractions instead of like pure Ruby. I mean, I could also write stuff in assembler if I wanted. I'll be totally in control about the registers and stacks, but I have no idea what I'm doing. So embrace abstractions and use libraries after you reviewed them, of course. Embrace the idea of simplicity, of encapsulating components into separate pieces of code without knowing what's happening outside, like the functional thinking. And it's really not that hard in Ruby because you have functions, you have scoping. I want to thank you for listening, and I'm on Twitter, but I don't use that shit anymore, so let's go to the pub. Thank you.
Thank you. Thank you, Nick. So we now open for questions.
Oh, I was hoping there was no question.
Thanks you all for your talk. It was amazing for me. And I have a question about your processing activity. What about the asynchronous steps that must run in background? Is there any specifics in activity process in such case?
For what? For background jobs?
Yep, asynchronous processing in activity flow.
So if you want to decouple things physically, if you want to, I'm not sure if that is the question, if you want to decouple activities and you want to run a part in a background job and another part in the... Well, if you want to have that few steps decoupled, you introduce a new activity and you run that activity and you trigger that activity with an event. So events are decoupled from the stack again. So it's completely simple. It's like what Benjamin was showing with the event listeners, which is the decoupled activity, and then you throw the event and trigger those steps. So that's again, BPMN defines how you do that kind of stuff, and we just have the mechanics already in Trailblazer.
Okay,
thank you.
There we go here.
Thank you, Nick, for the presentation. I especially like all those unicorns, traces, graphs and arrows. It was amazing. I have a question regarding all those recent slides at the end of the presentation about workflow and stuff like that. If I will use it, will I still need to write some code?
Of course not. We know what you want. We just give you a language, you model it in graphics, and everything works. You know, we had that 20 years ago in model-driven architecture, where you had this editor, and you would just drag and drop your application, and of course it worked.
Okay.
Great question.
Do you plan to make a plugin for Microsoft Paint to do this stuff?
Microsoft?
Yeah, Microsoft Paint to automatically represent it to your graphs.
Even better, Eclipse plugin.
Oh.
Yeah, that wasn't easy to copy the presentation, so the graphics are not too obvious, I would say. More questions, guys? Okay.
This conference is amazing. I've never seen an audience that has, after every talk, there were so many questions. It's really, really cool. I really appreciate that. And I think all the speakers appreciate that. So,
Nick, thank you for your talk, and especially for your model of thinking and the things that you introduced to our minds.
A lot of thinking.
So my question is that you start looking into the functional concepts, and I think you digged into, and maybe you already have some particular functional language that you like and you would suggest it on.
That is an unfair question, because I want to discover more languages. You know, I'm thinking of like, I mean, maybe not Haskell, but Clojure and Elixir. But I don't have the time currently to look into those languages. And I mean, I follow Elixir all the time, what they build and all this stuff. But I don't have any, I mean, we should just sit down and play with it. But I think it's going to be Clojure or Elixir or JavaScript. Yeah, just kidding. Do you have any language you prefer for functional concepts?
I think Elixir is pretty good and close to Ruby.
I mean, yeah, it's not that hard to be better than Ruby, to be honest. But yeah.
Question
Hey,
here.
RubyCon friends.
Nick? Question here.
Ah, here you go.
Okay.
Got so many questions.
Yep. Well, thank you for your presentation. It was really inspiring to see that someone uses just basics of discrete math like determined automatas and just lay it on your graph and everything works. And that's really inspiring to see that. And just a question. So you basically created the pipeline, something like the Elixir uses, and then took the graph, turned it automatas, and just laid it down, and then it works. Right like this?
Well, this is playing into the other question we had. You just create graphs visually and everything works. No, I mean, you still have to write code, right? You have to implement the steps, but Trailblazer tries to take away the control flow. So this is, you know, the same that Benjamin
Well,
was
that's
talking.
just high-level abstract thinking.
Well, it's taking away a lot of code you have to write, because otherwise you would have to write if this happens to that else. So you don't need to use Trailblazer, but you will save a lot of control flow code in your application, and that is not only all of it, because you can also visualize that control flow automatically, and you can trace it and all those other features I didn't talk about. So of course you have to write code. You have to still create a model. You still have to run a validation. You still have to run send an email to someone else. But it's way easier to compose that and to reuse components as
So
another.
you can just see it as a pipeline, generally.
A pipeline would be linear, but in BPMN you can have any kind of flow. So in this example with the one-time password login, you can see this is more than a pipeline. You know, you can, for example, if you type in your one-time password, basically it's a reset password functionality. So you get the reset password link, and if the link was wrong, you go back to the original state and wait for a new, for a retry. So this is not a pipeline. This is an activity. So you have more than the way onwards. You can also go backwards, and you can branch off to other branches. And actually, we didn't think that we need that, but once you have it, it's great.
Okay, thank you.
It's like drugs. Oh, I didn't say that. Okay, thank you very much. I think we all want to go to the
White in Talks.
museum.
White in Talks, of course.
Thank you, Nick.
Thank you.